Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series where we are creating a programming language from scratch. That's right. We're using a terminal window, Vim as our editor, modernish C++, and some nice tools such as Flex, Bison, ICU, um, a makefile, and our own ingenuity. And we have been slowly, I've said it from the beginning, if we're doing all this from scratch. So if we don't write it into our language, it doesn't exist. And we've been slowly adding features. And our focus lately has been Unicode encodings. And in the last episode, in the previous episode, we created a function that would take a UTF-8 encoded string and make it safe for HTML consumption. Now that means that there were 5 symbols that when we ran across them, we replaced them with the HTML encoding for those symbols. The less than, the greater than, the ampersand, the single quote, and the double quote. Why single quote and double quote? Because if you're doing XML, it's useful there. But anyway, okay. So, what we wrote though left the rest of the string in UTF-8. This was just a way of providing a safe string. Yeah, that's the easiest way to say it. A safe HTML escaped with the dangerous characters escape using the HTML and escape. What word am I trying to say? Encoding. I was going to say formula, but encoding is better. So what are we doing today? Well, what if we need something that's not UTF-8? What if we need something that is ASCII encoded, but we still want all of the Unicode characters? Our job becomes a lot bigger. That's what we're going to solve today. Now, the other thing that we did last time is that we, in fact, I can bring it up because I think I still have a window around here somewhere with it. Do I? Yes. We spent a while, I'd already prepared this, but we talked through it about what the encodings actually look like and how do we turn these into regular expressions for use by, we broke them down and figuring out what are the valid and the invalid sequences for UTF-8 sequences. And then how do we turn these into patterns that we can recognize in Flex? And of course, Flex it doesn't know anything about UTF-8 or anything like that. It chews through 1 byte at a time. And if you want anything special out of it, you've got to tell it what that special thing is that you want and how to act. And so that's what we did. We have all of these rules that will parse something as either valid or invalid. And we even have our own comments as to why something is invalid. But yeah. But most of the stuff that we didn't really need something this powerful in the previous episode, but I knew that this next part's coming up, so that's why I went ahead and did it. And we'll need it again for another part in the future. What we could have done in the previous one was just pass everything through, look at the characters, and when we saw those 5 characters that we were targeting, just insert the special escape sequence. For example, the ampersand becomes ampersand AMP semicolon, and the less than is ampersand LT semicolon. We could have just replaced those when we saw them, but I still put it all in this really big format. Well, okay. Today we're going to go for the ASCII encoding. And what does ASCII encoding of UTF-8 look like? I'm very glad that you asked. I have a Wikipedia page that has these XML and HTML character entities. So what this is when you come to a character of some sort, in this case, the exclamation point, you can replace it with, this says EXCL. That really means ampersand EXCL. Okay, ampersand EXCL. And, or ampersand EXCL semicolon. Or a quotation could be ampersand QUOT semicolon. Or actually, there's two versions. So you could do it in all caps, but I think I always chose the first one in my list. But there's the ampersand AMP semicolon. And go through this, and there's a really long list. And I mean really long. And again, you might say, well, why? Why would you want all of these? Well, the reason is that, like I said, this is converting all of these Unicode code points that must be encoded somehow. Before we were using UTF-8, but what if you need it specifically to be encoded in Ascii? This is providing sequences that are Ascii only. And then not all of the code points are represented here. There's a lot, though. But not all of them are there. So what do you do for those that are not present? Well, right here. You can just give the number. Now that's in decimal. This is in hexadecimal. That's fine. And you can even include leading zeros. That's fine as well. But, and in fact, you could actually encode every single character using this method, but we'll only do that for characters that are not understood as visible characters. Like, for example, A is a visible character. The space is a visible character. A line feed is not a visible character. So, yeah, you could encode that as, what is the line feed? Is it 10, which is A, or is it 13, which would be D? I don't remember. Oh, well, doesn't matter. We'll look it up soon enough, or figure it out soon enough. But that's what we want to do. We want to build this sort of encoding, and we're going to stand on the shoulders of our work from the last episode. Always said nothing up my sleeves. I haven't pre-prepared anything, sort of. Obviously, I did some work, and the problem is we have, let me open this back up. We have a big list of, I think, around 1,500. I've said 1,800, but I think it's only 1,500. Maybe it's only 1,400. I don't know. There's a lot. But these are all encodings, and we need it with an ampersand and a semicolon after it. And, well, that's a lot of work. So I did a little bit of prep work just to get the list together, because this isn't even in a list that we can do, and you don't want to see me typing this out. Ampersand LPAR semicolon for the left parentheses. I know you don't want to. So I did at least pre-prepare that, but all the rest of the code I'll be writing in front of you. So let's see where we are. If I say get log, the last commit was indeed episode 51. That's the previous episode. And if I say get status, no code has been created yet, so we're about to be doing this. And so let's see where we are. First thing we're going to do is I'm just going to go into Flex, and we've got HTML escape. That's what we wrote last time. And I'm going to copy that, and we're going to call this HTML escape ASCII. I think I was calling it HTML escape full, but I think it makes more sense to refer to it as ASCII. And in our includes, what do we have? There is an HTML escape here. We're going to call it HTML escape ASCII. So we're going to copy HTML escape and HTML escape ASCII.hpp. And now our make file, because we need to add it to the make file. So let's HTML, just search for HTML. Here's one. So copy it and put HTML escape Ascii. Look for the next HTML. Here's one. And ooh, I'm let's see if I did this right. This should how do I do it? To do the replacement using relative stuff. I think dot, comma, and then dot plus 4, will that work? To substitute escape with escape Ascii. Yeah, it worked. Hey, that's cool. I need to know. I need to do that. The only problem is evidently this didn't. I didn't have it in the right way. So this should be HTML escape. Okay, let's look for the next escape. Oh, here's one. And can I now use the same escape with escape Ascii? Yeah. Okay. Where's the next place that escape appears? The test Unicode string. So this we can't use the trick, but is there any other place? Nope, we're back at the beginning. So I'm writing all of that, quitting, and now on the right-hand side, we'll say make clean, and then make test watch, and this will get started with the compiling. And of course, the first thing is that it's going to say I've got a duplicate definition. Yeah. Okay, so we got to fix that. Where is this going to be? This is going to be in, we need to modify the well, let's do the flex. Flex for HTML escape Ascii and the include for HTML escape Ascii. All right. And in this case, we'll just say, so globally, we're going to replace escape with escape Ascii. And see if that is working so far. And we'll do the same thing here, replacing escape with escape Ascii. And we'll do the same thing with capital ESCAPE with ESCAPE escape Ascii. Okay. See if it starts compiling now. That would be nice. It looks like it is. All right, and we're going to edit the test file. And which test do we want to do? The Unicode string test. And we've got our unescape test, we've got our HTML escape, and now we're about to write our HTML escape. Can I do this here again? What I'm wondering is, can I say, do my substitution, but instead of 4, say plus 22? Yeah, okay. I told you I'd eventually learn how this worked. And all of these, oh yeah, of course I can't do it yet because I haven't included the header file for it. And evidently that needs to happen in Unicode string. So I'm going to edit the include for Unicode string.hpp, and it's not there. Did I really just quit out of that? I didn't mean to do that. test Unicode string. Oh, okay, yes. HTML escape ASCII. That's it. I don't have a function that does that. That's what we need. Okay. I remember what I'm doing now. It's not that I need to include something. I need to actually write the function. So the include for Unicode string, and we're just going to copy that, return an ASCII only. All right. Replace all of that because it's all wrong. And we will say that only visible. Wait. Convert all into an ASCII only representation, and I need that on a new line. ASCII only representation of the provided UTF-8 encoded string. Visible standard ASCII characters will pass through what unaltered, but all others will be replaced by their HTML escape sequence if it exists, or the appropriate hexadecimal escape code. There we go. That's what we're doing for this, and we need to add the word HTML escape ASCII. Now it's not going to exist yet, and it's going to complain about that, but we're about to make it exist. And how are we doing that? We edit source Unicode string. And we've got HTML escape and HTML escape ASCII, and we're going to do the same substitution thing, except for now instead of 22, it's just going to need to be, how about 9? There we go. Oh, HTML escape ASCII was not. Now we do need the pound include. Not going to work. I mean, well, no, the test won't fail yet. But we're about to make them fail. All right, so let's start off. We're going to say the test, there it is. So the, sorry, I went down, I should not have, it's just right here. HTML escape ASCII. There's a whole bunch of Unicode stuff. There's the empty string, we want to keep that. This should definitely be less than, greater than, ampersand, quote. But there's a few others. These are not going to be right. It's not going to be it's not going to be a /a. It's not going to pass these through. We hope. So, you know what? Let's just start writing this. And in order to do this, we need to edit the flex. Yeah. So after we define the YY terminate, we've got more code to go in, and actually set paste. And the reason I'm doing this so that it doesn't do any weird indentation stuff. So first of all, what do we do with an unknown character? An unknown or error character. So what we're doing is we are now not just passing through Unicode. We are, excuse me, UTF-8. We are taking a UTF-8 code encoding and converting it into something legitimate. The problem is what happens if we find one that's broken. That is what do I mean by broken? Sorry, brain stopped working. Thinking is hard. Incomplete, something like that. Invalid. We can't encode that because we're only encoding valid things. So we need to put something there. And the answer is, I believe, don't I have this? Thought I had it. Unicode replacement MENT character. There we go. We want to replace it with this FFFD. And how do we do that? Well, we're going to provide it. So will be represented by the replace that's probably long enough. Replacement character as by the UTF-8 specification. Do I have a speckling for that though? No, it's in like the chapter 3. Where's my Notepad++? Yeah, I think I like this better. I like that wording better. So there. And now it's probably too long. No. That one's not too long either. Okay. Yeah. There we go. And can I do this? Constant expression. I've never used them because I've never needed to, but let's try. String. We'll call it unknown. I'm okay with that. And it's ampersand x FFFD. Yeah. Because that's what the FFFD. There we go. Again, FFFD. Okay. Get rid of that. Now, what about the mappings? This is where you're going to have to forgive me. Because I'm going to copy and paste. You'll see why in a sec. Alright, so now I'm going to need to do set paste so it doesn't try to do weird stuff. Yeah. Okay. How long is this? Do you see what line number I'm on? 1516. What this is, or what I created was, if I say percent, yeah, there it takes me to the beginning of it. So I created this, why is it indented? It should not be indented. Can I say ZC? And now, there. That was just to fix the indenting. So what this is a character map where we're feeding it an unsigned int will point to a string. And in fact, forget that. Let's make this a uint32t. Try to be consistent. And so here's the first one. Tab is ampersand tab. And so on and so forth. And if we go through, this is the list. Like I said, you did not want to sit there and watch me do it. This took a while. Oh, I have a... Where was that? Those didn't need to be there. Did I lose any? Nope. There we go. Let's just write that. Map does not name a type. Well, that's what you think. And for the sake of this, let's just, I didn't mean to hit percent. I meant to hit ZC. Why is that? $11.08. Let's go to line 11.08. And what's above it? Nothing. I mean, I don't know. Huh. It's up here somewhere. Why is it not folding any further? I don't know. Okay. Don't know why. And it doesn't like this. It says, oh, string. I need to pound include string. The type const string is not literal. You know what? Okay. I'll just declare it this way for now. I'll worry about context spurs later. Now it's not doing anything, of course, but we can start something here. What we're going to do is, let's just go to line 1500. Okay, that puts us near the end. That's good. And for the 1 byte thing, I'm just going to say if, what did I call this map? Char map. charmap.count, and what am I looking for? What is the number? Well, first of all, we've got to uint32t. Well, is it really? Yes, it is. Num char sub 0, so that we're matching 1 byte. And if there is something at num, set no paste, there we go. If there's something there, then return char map at num. Just return whatever it is. Else, pass through. That's the first little bitty change we're making. YY text. That's what it should have been. YY text. Okay, so now it's saying stuff has failed, but it probably hasn't failed for the reasons that you think. It's not that things are broken. It's actually, look at what failed. We've got some things here that, ooh, the hat. That's going to be the caret, percent, dollar, num. It's working. Okay. We see that the ampersand or the /n is ampersand new line, semicolon. That's correct. That's the tab. The $sign got encoded. Yeah. Okay. Let's make this a bit more robust. I think I want to have this as a function. So why am I doing it this way? Because, well, we'll want it. We'll want to copy the logic. So first of all, I'm going to say it's going to be a string, and I'm going to call it decode 1 byte. And the string, there we go. And let's steal that, and we'll say and instead of YY text, we'll say S, else return S, and now we'll say return decode 1 YY text. See what happens. Okay. Let's see. We're still getting things decoded. That's good. All right. Now, what else? Well, okay. Decode 1 is now a function that's being included in this object file. The problem is I don't want it to pollute the outside project. It is just for use in this one object file. So I need to protect against that. And how do I do that? By putting static in front of it. Okay, and S is now a reference that is a constant pointer to constant chars. That's just promising I'm not going to change anything and letting the compiler verify that. And now I need a way to, instead of S, okay, if I'm here, first we're going to say HTML escape sequence if it exists. Okay. Else, if it is a printable character, pass it through unaltered. How do we do that? That's your standard isPrint. Everybody should know that one. So if isPrint, and it takes a char, so S sub 0, then, you know, we can just say return S. That's fine. And then lastly, for this one, we what do we need to do? We need to encode the byte as a hexadecimal value. And what do we want to call this? Let's call it get hex escape code, escape sequence, escape. They're all called escape sequences. Sequence, why not? And what do we pass it? Oh, the number, right? Because it's a number. We haven't written this function yet, but we're about to. So get hex escape sequence. What is this? First of all, it's static string. And if I just say this, if I say return nothing, just to see if it compiles. Oh, I need to say what type it is. And this should be a uint 32t. Unused parameter, I know. Okay, now let's see what we've got. Okay, so this /a, which is the alert bell, is that like number 7? I don't remember. It's been a long time. It's coming across as nothing, so it tried to call the get hex escape sequence. Or is that the bell? I don't remember. I'm old and forgetful. These are the form feeds, but these haven't. But what about these up here? We still have our percent, and the hat and ampersand came through, and the printable ones came through. BAC, blah blah blah. All right. So what should this look like? Well, how do we do that? Calculator. So the calculator, just using it as a quick tool, we know that the largest value that we can represent is 1. Well, I could do the math. I'm doing this for the sake of argument. 1, 2, 3, 4. Well, that's a total of 5, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Wait, did it get 21 in there? 18, 19. Nope, it stopped at 19. Why? I guess you can't represent 21 bits. The point is the hexadecimal. Oh no. I was typing it in decimal. I meant to be in binary. My fault. Let's try that again. Binary. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Right there. FFFF, and then an F1. So 6. And then what does it look like? It looks like ampersand. Are we going to do... Going back to this. Yeah. I want to do the hex version, so you got to put an X, and then you put all of the digits, and it may include leading zeros, and this may mix uppercase and lowercase, although uppercase is the usual style. All right. X, and then the largest we said is 6, so let's say that's the largest one. F, 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 F. What else do we need? Semicolon? Yeah. How many bytes is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the largest buffer required is 10. Hexadecimal characters plus the null terminator. So we're going to create a char buffer of size 11. Sure, we can do it that way. We're going to need an sprintf, aren't we? Well, wait, first, we're doing a number, and I want to make sure that we're safe. So if num is greater than ox 10ff, right? That's from last time. then return unknown. That's our const string. So this is going to ensure the number isn't too big. And all right, and lastly, create the escape code. How are we going to do that? Let's see, sprintf, and we have to have our our buffer. Why am I using two F's? Let's just use one. Our buffer, and then the pattern, and then num. So what's our pattern? Well, we know we've got the ampersand, pound, x, all those should come through, but percent, where are you? sprintf. The format in printf, there we go. Uppercase, unsigned, hexadecimal integer, x. So if we do percent capital X semicolon and return buff, let's see what happens. It's going to fail. Oh. Semicolon. Okay. This is looking a lot better now. So how is that? Well, you see this A? It is 7. Hey. B. Oh, that's not the bell. A is definitely the bell. It's the alert. B, I think, is the backspace. Yeah. And this looks right. Number 8, the form feed is 11. New line. Oh, that came across as ampersand new line. That's fine. But I think that's 10. Yeah, it has to be 10 because the carriage return R is 13. That's the other one I said earlier. The tab came across %T. This is the vertical tab, which is B. That's 11. Yeah. No. Yeah, it's 11. Sorry. And the null came across as ampersand pound x0 semicolon. That's all right. And this one, where we purposefully did one, it came across as ampersand pound x1. Okay, I'm liking this. Let's fix our tests, at least on these. And where is it? Our test. Where's our test? So we know that this should be ampersand pound x7 semicolon. Oh, I said ampersand, not that. Ampersand. There we go. The back should be ampersand pound, x8 semicolon. Ampersand pound xc semicolon. The new line is ampersand new line semicolon. This is ampersand pound xd semicolon. The tab is ampersand capital TAB semicolon. The vertical tab is ampersand pound XB semicolon. And this one is ampersand pound X0 semicolon. And this one should be ampersand pound X1 semicolon. Did I get all of those correct is the question. So far, so good. All right. Let's make some more progress on this now. So this is our decode 1. And if it's a valid 1 byte, we use decode 1. If it's invalid, we're going to return, instead of invalid, I want to return unknown. So for all of these, I'm going to so 1559 through that. Okay. 1559 through 1648. What are we doing? We are substituting YY text for unknown. Now a lot of other stuff's going to break. It basically replaced things with a lot of FFFD. That's the unknown character, because it didn't know what to do with it yet. That's okay. We're about to fix it. We're going to do a decode 2. Hey, that worked. Control A will increase the first number in the string in the line that you're in by 1. It does, doesn't it? Or do you have to be? Oh, it's the first one after your character, and then Control X will decrease it. What happens if we get down to 0, negative? I wish I'd known this before. Live and learn. So now the number is different. So where is my notepad? Here we go. We need to pull the bits out of this. How are we going to do that? You know, let's do this. Let's do num. I'll call that like that. Num0, num1. Do I care? We're going to do something with the number. I'm just... In short, okay, it's going to be num0 bitwise combine with an OR, so it's going to stack the bits with num1. But I need to do something to the num0, and I need to do something to the num1. The num1, that's going to be the second one. If I... Where's my calculator? So what's that value? Again, I'm in binary, and the lowest 6 bits. 1, 2, 3, 4, 5, 6. 3F. So if I do a ampersand with 0x3f, that will mask off those lowest 6 bits. What about this one? I need the lowest 5 bits. There we go. Can I back off one? Lowest 5 bits are 1f. Oh, of course, 1 followed by f. Oh, I should have known if the 6 would then be 3f. I know my hex better than that. I just forget it at times. But 1f. All right, so if I ampersand 0x1f, and then shift it left by how many? 6, of course. That should give me the number. Okay, I'm no longer needing to do the printable test because nothing's going to be printable if it's that big. And now is that right? Yeah. So I'm just going to be looking forward to know that I'm going to have to do this again. That number's not going to change. This is going to get smaller. So instead of it being 1f, it's just going to be f, and then it's going to be 7. Are we encoding stuff? I think it's working. Well, almost. You say, what's the almost? I haven't said where to use the function, but it did compile. That's always a good thing. So instead of decode 1, for a valid 2 byte, that would be right here. Are there any other valid 2 bytes? No. Okay. There we go. Again, shouldn't break. Do we have any tests that are 2 bytes? Where are my tests? Oh, 3. Oh, that substring. Let's escape ASCII, and what do I want? I want the British pound character. There we go. The pound sign. but encoded in UTF-8. That's what it is. It's A3. But it should be a 2-byte encoding. Oh, I had a site that I could look this up on. One moment. Code converter for the pound sign. There we go. And UTF-8. That and we will say that this is a 2-byte Unicode character. Pound sign. I'll just call it pound sign. And why am I saying currency? Because hashtag, what's called a hashtag now, is also known as a pound sign. I know I've got it as ampersand less than. That should fail, but it will tell us. There it is. See? Ampersand pound. And that is correct. I knew it would be. Pound. There we go. Now that one's going to pass since I'm saving it. Let's do the same thing and get a 3-byte. And I happen to know of a 3-byte one. I just have to look it up. Where is the browser window again? And this is the, let's say, yen, but the symbol pretty sure it's actually I was thinking it was just the first one. I don't want to use that one. Well, I don't know if it's a am I right or wrong? I don't know Japanese. I'm sorry. I apologize. But the whole point is it's a 3-byte. And so word. So that's the symbol. I suppose that's the actual word, but I will currency, and let's leave it there to break. It should come across as unknown because we haven't written how to do this yet. All right. So we need a decode 3. We've got our decode 3, and this is going to be, okay, that's our 3 numbers. And what do we do here? We need to say shift it left by how many by 6, and then this needs to be, instead of 1F, it's just F, but shift it left by 6 plus 6, so should that be 12? Am I right? I think I am. Oh. 0, 1, and now 2. That's why you turn on warnings. Of course, it's saying, haven't used decode 3. That's fine. We're about to do that. So where do we need this? We have decode 2 here. So valid 3 bytes. Decode 3. Valid 3 bytes. Valid 3 bytes. Invalid, invalid. Because that's a surrogate. So, and then valid 3 bytes. Did I mess up any of those? Should be right. Oh, this one. 5186. Is that right? Where is this? It is 5186. Okay. So and notice it did not we didn't have a symbol for it, so it did it as a #X 5186. All right, and last but not least, we need to do our 4-byte ones, which oddly enough, I think most of the flag ones are 4 bytes. Is that right? I believe so. Easy enough since I'm here. Let's put the decode thing in the right place. So valid 4 bytes, valid 4 bytes. Nope, I didn't put the fact that it was 4. There we go. Decode 4, valid 4 bytes, valid 4 bytes, invalid, invalid. All of these are invalids. Okay. And now go up. Decode 4. Got our 3 strings now, and we're going to alright, so this is no longer F, this is a 7, and so 6, 6, and then, oh, not 6, this should be a 12, and then this should be, is this 18? I think so. Oh, not using num3. This should be num0, num1, num2, num3. Always compile with all your warnings. All right. Okay, so Look at this. It did, in fact, give us the Unicode encodings. That's good. And these are still, AA is an unknown, because I believe I just, wait, is that right? AA? Yes, it is. Intentionally it is, right? It's it starts with 1 1. Wait, no, it's 1 0 1 0 is A. This one is invalid. But A is 1 0 1 0. Why isn't that? Let me think about that for just a moment. Either way, go to the tests. And let's fix the ones that I'm positive of. This one, I'm definite sure it should be FFFD, because that one is an invalid one string, or 1 byte. Let's see. For this, I am going to cheat and grab all of those. Wait, am I putting it in the right place? I think so. What did I just do? Should be, I'm using an escape sequence. It should be ampersand x FFFD semicolon. Wait, there should be a semicolon there. Did I leave that off? Replacement. Sorry, I'm just wondering if I made a stupid mistake. One moment. Yeah, there should be a semicolon at the end. Is it not including it? Oh boy. It's at the... Oh, there should be a semicolon there. All right. The hexadecimal value AA, hex AA, is the binary value. Oh, of course, yes, no, that's not valid. You can't start with a 1 0. You could start with a 0 1 1 whatever, but that's one of the tags. So I remember writing that test now. The moment I saw it, it was like, oh yeah. There we go. So that one should be fixed. We're almost done. We're almost caught up. And so line 62. Where on earth is the difference? All right, so we've got all the alphabet. That's fine. We need ampersand EXCL for exclamation. ampersand COMMAT, ampersand NUM, semicolon, ampersand dollar, ampersand per CNT, percent, is that hat? Yeah. Ampersand capital HAT, semicolon. The ampersand we've already got. The asterisk, yep. So ampersand AST, semicolon. The left and right parentheses. Ampersand L par, semicolon. Ampersand R par, semicolon. The accent grave, is that right? Grave. The tilde is not escaped. What about the left square bracket and right square bracket? Yes. So ampersand L SQB and ampersand R SQB. For the curly brace, CUB, cub? Okay. So ampersand L cub, ampersand R cub. And what about the pipe? Vertical bar, ampersand V, ampersand VER bar, verbar. All right. How about a semicolon? Yes, ampersand semicolon. Okay, I left it there. The colon is ampersand colon. And I got the apostrophe. Comma is fine. Period is fine. Less than, greater than is fine. Oh, no, wait. Sorry. I was thinking about this wrong. Ampersand comma is not fine. We fixed it. Period. Period. Is that? I need to do that one. Ampersand period. Question mark is okay. Space is okay. And ampersand quote. See if that got them all. I'm missing something in there. I'm missing just one. Oh, the question mark. Ampersand quest. But that's it. I'm happy about that. Okay, so what does this give us? This gives us the ability to take any UTF-8 encoded string and turn it into an ASCII safe HTML escaped string. And all that we had to do was have about 1,500 lines of definitions of what the different values are. And by the way, if I go up, you'll see that it has code point, like the last one is code point 120,171. And if I go up, eventually it'll yeah. So it skips from 64,260 down to 119,000. So yeah, there's a lot in there that it doesn't have, but I guess that's all the scroll characters. And anyway, so all that we had to have was a way of turning a number into an escape sequence, and we used the old sprintf for that. And decode 1, decode 2, decode 3, decode 4. And yes, our number for the escape sequence is we make sure it's not too big. So, do I need to add any more comments? I think we're okay. As always with cutting and pasting, or copying and pasting, as I did more here, it always scares me that maybe I missed something. So if you see something, let me know. And as usual, I'm going to say make clean and then redo the make while on the left hand side I see all the differences. All of our tests. All right. Flex. All right, include HTML escape. Ascii Lexer and function to the Unicode string. I'll say library. Sure, why not? And now, make docs PDF. Let this run for just a moment. Evidently, our PDF file is now 366 pages long. We can see that there. And our, where are we on here? 8,000 lines of code because of the big thing that we added today. 2,500 lines of comments, but all right, so git status, git add docs, just to make sure, yeah. For episode, what episode are we on? Episode 52. For episode 52, yeah. Yeah. All right. And I already did I can't speak. I already did this. But we've got it. Okay. Now, is that all we're going to do? No, we've got one more to make, but it's easier. Now that we've done this one, it's a lot easier. What do we need to do? Well, we need to add a percent encoding. Why do we need that? Because we're generating HTML documents. And if you need to generate a URL, you have to output it in a percent encoding so that it's safe to pass into a URL bar. And that's a different encoding altogether. And you probably have seen it. And percent encodings aren't just percents. For example, the space becomes a plus sign. And yeah, but we can do that with Flex as well. And the whole point of this is that we're using Flex for something other than just building a language, even though we're obviously using it to build a language. In fact, the more I've dealt with it, more I've worked with Flex, and I mean this not just in creating this series, but just worked with it in general, the more and more use cases I saw that, ooh, you could just, do that. I was thinking of parsing HTTP headers. Same way, Flex would make it really quickly. really quick to do that. So anyway, all that saying, it's a great tool. And like I said, we will pick up just kind of adding to our library of functions, and then after we get the percent encoding, we will add this into our language of ways of saying, I want this variable printed out using an HTML encoding, or using some sort of value. Yeah, we will leave it at that. And let's see, is there anything else we need to add? I don't think so. So, as always, I want to thank you for joining us on this trip, journey for me, and hope it's been enlightening for you in some ways, and hope it's been fun. Thank you. Have a great day.